Hello and welcome to this episode of the Test Box, where we're putting in the HDPE walls. Now, the inner HDPE walls are the first line of defence in the test box. So if a spinner is going round and it hits the wall, that's the first thing it's going to hit. So it's really a sacrificial part to make sure the polycarb doesn't get damaged. These are being fixed in by longer M8 screws, so I can actually put the HDPE wall a good few centimetres away from the polycarb, so you've got a bit of air gap there, so the HDPE absorb the full shock of the hit. They also have the added benefit of adding more structural strength to the box. So the middle wall I'll put across the place where the two polycarb panels meet, so you can put some screws in and that's extra strength there on that side, and the same for the other side of the box. Now, towards the end of this video, I'm going to be explaining about the principles behind the test box door. This is quite a major part of the test box, as this is going to have where the locking bar slots through, and it's got to be secure and have its own structure. And also, not only that, it's got to have some heavy duty hinges, so that if for any reason the rope hits the bottom of the door where the hinges shouldn't break off. The test box door will also have its own HDPE inner wall, using the same principles as the other walls around the box, and this will interlock with the other parts of the HDPE wall as you close the door. You'll see this more and when I mocked up the test box door on the CAD. So here we are installing the first HDPE inner wall. This goes on the rear polycarb panel on the test box. As you can see here, I'm using the longer M8 screws, and then I've got an extra set of nuts and washers to hold the HDPE wall in the correct position away from the polycarb panel. This works out at about 5 to 6 centimetre clearance from the polycarb panel to the HDPE wall. So then the following pictures are now installing the mid walls on the test box. As you can see here, they add some structural strength because they're actually, the HDPE inner wall is going across the transition between the two polycarb panels, and so when it's fixed into place you get extra structural strength. So you can see here we've got the HDPE walls on both sides done in the same way. These walls are all cut from 1 metre square HDPE panels. So after I've cut the remaining parts for the HDPE walls, I can actually give a little mock-up here where I've placed all the panels where I'm expecting them to go. And there's further refinements here to do where I'm cutting off small parts of the corners of the HDPE walls for clearance to various things. The main one being the HDPE wall on the door. On this picture you can just about make out the small corners I cut out to enable clearance to the other screws. So once I was happy that these walls meet up at the corner, then I could move on to designing the test box door. Now I'm still pretty new to CAD, although I've had it for a little while now, but there's plenty still to learn on this. So these things are just various angles on the CAD mock-up I have of the test box door, interfacing to one side of the test box. This allowed me to design for the remaining HDPE parts on the test box door, making sure they didn't clash with the remaining HDPE wall, and also line up where the locking bar was going to go through the test box and through all the HDPE attachments to the test box door. Luckily I'd already bought a spare HDPE panel that I was going to use for the HDPE walls, so I had enough HDPE left to cut the material for the test box door attachments. Now these attachments have a new design I'm trying out, which is based on inserting barrel nuts onto HDPE. Except in this case it slots in the HDPE, so I can actually put a regular nut in these holes, making sure the HDPE parts are securely attached to the door, and so a robot can't just smash the HDPE parts out of the door if there's a case where it hits the door, which would cause the door to open, so that's a failure point I don't really want to have. So I've made sure I designed around that. And this is just a 360 view showing off the various parts of the CAD design. From here I could actually start putting in the physical parts of the test box door. There's also on the CAD design the small HDPE frame, which allows me to line the test box door up to the test box more easily, which you can also see in the following picture. This is the start of the physical test box door build, where I've already cut the parts for the HDPE door frame, and I'm cutting the first parts for the HDPE door mounts, which will allow the locking bar to slot through the test box door and the sides of the test box. I've reused the Hardox mounts from the old Gunblade 1 design. So that about wraps up this episode. So I've gone through the HDPE walls, the inner walls, and the test box door. Now the next episode will focus more on the physical door itself, and it's basically step by step of how I've gone through building that, and some nice little design features I've added to this variation. So I'll see you in the next episode. Bye bye.